you got this set of y versus x data. You want to find a least squares approximation. Because what you want is you want a function, a linear function, that fits all this data. Ain't gonna happen, okay? Because these change by the same amount and these change by different amounts, okay? Quadratic fit might be better, but it wouldn't work, and you could do that, you know, just have another column, another parameter. But we'd learn to do it with just one, okay? Just a linear fit with two columns, okay? Or with two constants here. Because a quadratic could be like a c2x squared plus c1x plus c0. It'd be mapping onto a bigger space, okay? So, ain't gonna happen. But how close can we get? Okay? So you set up a transition, or a matrix product, AX equals B, where X is C0, C1, and B equals this. Okay? So that's really just this, isn't it? So this could be written this way, C1 times 1 plus C2 plus C0. Getting my notation screwed up. Call this C0. Okay? And I guess I want this one to be C1, C0. Sorry to mess up the notation, but okay? I gave it back to you yesterday in physics.
Okay.
You should have everything.
All right.
Because I was thinking, what did I do with it? I laid it out someplace? No, I remember. I think slid it across the table.
Yeah, you gave me the math set.
So check and make sure you got everything.
All right.
If there's anything missing, email me.
Okay.
I'll find it
All right.
and mess it up for you.
Thanks.
See you. Okay, so anyhow, you got this, and then you're going to have 2, 1, 3, 1, 4, 1 equals this, right? So now I've got 4 rows to match the 4 numbers there, and everything works out, and this is totally equivalent to this. Okay? And again, it ain't going to happen. So what you have is you have an R2 over here that you're mapping onto an R4 over here. And you've got your image space and you got your null space. Okay? So I'll put an N here, so that's a null space. I'll use I here for image space, but that's the identity matrix. But you know, Richard's got to leave. So everything in here goes into here. But this vector ain't in here. Okay, so this vector is that blue dot that I had outside of here. Okay? So what we want to find is the vector over here, which is a C1, C0, that makes this as close to this as possible. Or that makes a vector in here that's as close to this as we can possibly get it. Okay? What vector in here is as close to this as possible? What vector did it come from? The vector that came from gives us our C1 and C0 that gives us our model. Okay? I kind of had it backwards. I almost said it backwards again. Need to think a little more better. A little more better. That was good. Okay.